So in the previous video, we talked about edge detection by finding the gradient of the image. And we find the gradient of the image by applying either the Sobel or the pre-width operator. And these are what the kernels look like. This is a Sobel operator in the horizontal direction. And this is a Sobel operator in the vertical direction. You have the pre-width operator in the horizontal direction. So you see that it's trying to find edges that's going this way. And you have the pre-width operator in the vertical direction. I'm just too lazy, I didn't really draw it. So now that we've got that out of the way, we're going to talk about more advanced edge detection, which is what Dr. Lee talked about today, and that is the Canny edge operator. The Canny edge operator is something that's invented 20 years after Sobel and pre-width in 1986. Canny edge operator is built on top of the Sobel operator. Essentially what it's saying is, after you have turned the image into black and white, filtered out the noise using a Gaussian or medium filter of whatever sorts, then you have already applied the Sobel operator, but the edges are kind of thick. And what you want to do is you want to improve the performance of the Sobel operator. So what do you do after the Sobel operator? So suppose you have an image and you have the edges. This might be out of frame, but I'll try my best. This is your little weird 4-pixel image. So suppose you have some possibilities. Actually, that's a bad example. I'm just going to do this. This is the width of your edge. And you can see that the edge is less intense on both sides and more intense in the middle. So what we can do is we can do maximum thresholding on this edge by looking at this and see, well, we can see that the center is the most intense and the sides are not as much. So we can just get rid of the sides. And now we have an edge that's 1 pixel wide. So really, really thin edges. Thin edges are better than the thick edges. That's what we're trying to do here. And the way we would do this maximum thresholding is we would look for the thickest part. So we will compare this value to this value and to this value, to its neighbors. This is if the direction is 0 degrees. If the direction is 45 degrees, I don't know why I did that, then you will compare this pixel to this pixel. So you would do a comparison this way. 90 degrees, you will compare it this way. And you get the idea if I do it that way. So that's how we would compare and find where the thickest point is. Now obviously, if you have something that is 90 intensity, 80 intensity, and 70 intensity, then you this is essentially saying that it's going down. So you would actually cancel out all three of these pixels. So these would all get suppressed. So you would only get the edges when it's here at the maximum. So now that we get that out of the way, we also need to consider the direction, not this direction. Because what happens if an edge, let's see if I can get 2 ideas in one video without taking too much time. Suppose you have an edge, it's like this. So to find the edge that's like this, you will compare the pixels this way to find the intensity of the edge. But what happens when you get here at the corner? You'll have to compare the thickness of the edge this way, and you'll have to compare the thickness of the edge this way. So here we'll need to consider the difference in the angle between the edges. The heuristic that we talked about in class for maximum suppression is if this angle is greater than 45 degrees, then we do not suppress it. We do not suppress that pixel. So in this case, we can see that it is greater than or equal to 45 degrees. It's greater than 45 degrees. So it's 90 degrees, so we don't suppress it. So we don't suppress this pixel. So then we get here, and then we would compare it this way, compare it this way, compare it this way. And that's how we would find maximum suppression for the Canny edge operator.